Three, two, one. Good evening, morning, and afternoon, everyone. And you are joining us today on an episode about machine learning ops and Go.
Let's do it. It's go time.
Hi. I am joined today by my co host, Johnny. Hi, Johnny. How are you doing?
Hello, happy New Year. This is like my first episode since the year started. It's the first episode of 2022.
Wait, is this really just the first
My
episode of
first
this
my
podcast for the year?
No, I'm sure we'll release some already into the
But
year.
this is the
This is
first one
my
recorded in
first
the new year.
record for me at least.
I'm not sure there were other episodes, but we will find out. Mystery. And we are joined today by Mike Eastham. Hi, Mike. It's great to have you.
Yeah, it's great to be here.
And you are joining us from the overseas side, or from Johnny's side of the overseas. So you two are based in the US, but you are based in Brooklyn. Johnny, you said multiple times that
Maryland.
Maryland.
Not too far actually. Both East Coasters, yeah.
Yep.
Is there a time difference between you two?
Nope.
Okay, fun. Well, we have 6 hours apart to here, to Berlin. So that's 9 p.m. here. Fun way to start the year for me. So, Mike, you are a tech lead and a software engineer at Tecton. Or Tecton AI, I should say, because the name of the product, as you told me, is Tecton. And Tecton is building systems to operate and manage feature pipelines and datasets for production machine learning applications for all sorts of customers that we all know. And you used to be a Googler. And in Google, you were working on indexing and serving infrastructure for web search.
Yep.
Fun. So, can you tell us a little bit on where you work and what do you do there?
Yeah. So Tecton's a company that was founded like late 2019. The co-founders were all at Uber prior to starting the company, where they worked on a feature store product or internal product called Michelangelo. I think we'll get into in the podcast what it means to have a feature store product, but that's kind of where they met each other, got to know each other.
And I will pause you for 1 second to say that all the different names that you're mentioning, for example, Project Michelangelo, we will include in the show notes. So if you want to read more about this fun project, you can find it in the show notes.
Yeah, definitely. So yeah, the company was started around 2019. I joined March of 2019. I was like the outside of the founders. So I've kind of worked on pretty much every part of the product since pretty near the beginning when it was just very early prototypes to where we. So the company is like 55 people now around there. The got a couple different sub teams in the engineering team, so we're, I would guess, kind of a mid-sized company now. And our main product is this, proprietary feature we've been working on since the beginning, but we've also started contributing to another open source feature store product called Feast. Kind of the lead maintainer and starter of the project works at Tecton now, so we're kind of working on both those.
So both the products, the enterprise and the open source one, are feature stores.
That's right.
What's a feature store?
Yeah, so I think it's very kind of buzzwordy term. I think you'll probably see a lot of people trying to explain it in different ways, a different idea about what it is. But
we just went through the whole serverless thing, so we're
yeah.
We're a
New year,
customer.
new term.
New year, new term.
So yeah, I mean, I'll do my best to give my take on what it is. So I mean, feature stores kind of they're part of this like broader concept called MLOps, which you mentioned before. Kind of applying like a DevOps style mindset to getting machine learning applications into production. Feature stores aim to solve kind of one piece of that pipeline, and that's managing feature definitions and feature data. So you can kind of break down into a couple different components what a feature store is. I would say the primary thing is that it acts as a source of truth for definitions within your organization or your team, whoever's like working on your model. Is that you just have a single place where you define what a feature is instead of having kind of multiple different copies, potentially of the same feature definition, or just having a bunch of different systems where all of your features are all spread all over the place. In our case, we have data scientists and data engineers define those features generally as a SQL query, which is kind of a tool that those types of roles are typically familiar with. And the idea is that they can do it in one place and not have to prototype it using SQL and then later hand it over to another team that builds a production version of that feature using Java or Go or something like that, and then have those things get out of sync. So we really the first aspect is just having a single place where the feature is defined. And then you can.
I will pause you just here to go one question deeper and ask for those who are just really focused on like backend web servers and in that little world, what is a feature?
Yeah, that's an important question. Yeah, so I mean, you could probably have a very kind of like mathematical definition of this, but generally, like the features are sort of the engineered inputs that go into a machine learning model. So when you're in the process of making a machine learning model, you sort of have an algorithm that takes it and it uses those to predict an outcome. And generally, when you're building these systems, that you kind of engineer those values to encode some sort of like domain knowledge about the system you're trying to model. So if you have a bunch of, let's say raw data about user system, and maybe you're trying to predict like a product they might be interested in buying, as someone who kind of, knows a bit about how, what might predict what people might want to buy, you might say, okay, I think their age might be, kind of an important determinant of be interested in. So then you can build a feature that based on your raw data, let's say like a database of all of, your user information, just extracts the age as a number. And so you're kind of down things that you think might be important to the model training system. And that process is like super important for building models that actually perform well, because the model training algorithms are now actually quite sophisticated and they can produce really good results, but you're always going to get better outcomes if you kind of have better data going into the training.
Is the objective of a feature to make it a reusable part of the workflow for building these models? Or what is the objective of having a feature?
Yeah, so I think definitely in an MLOps context, you might say that like you can certainly build machine learning where all of done in a silo and you don't reuse it across different models ever. But you're probably going to have better outcomes for your organization if you ever. You're probably going to have better outcomes if you can kind of share that work across different models. And so that's definitely something that people try to use feature stores to achieve.
Now, how granular? Like you gave an example about sort of having a deterministic way of getting someone's age, right? Giving your data model, your schema, your data store, whatever, wherever you're storing your user information. Is the point to have these things sort of very granular to the point where to ease their reuse, because they are like very small in scope. They do one thing and one thing well, kind of thing, and then you can just chain them as part of your model.
Yeah, I think some of that depends a bit on what types of techniques you're using to build the model. So from the perspective of someone who's building a feature store, we kind of just want to make sure that we support whatever types of features that people want to encode in the system. And so you can have really generic things like age, but you can also get, even super specific features that are, something that's like specific to a certain product and user combination. So I think there's like a variety of answers to that.
So a feature then is part of the set of inputs that you're feeding into your model?
Yeah, so you use it both. So you'll provide basically a bunch of previous examples of feature values as well as the outcome. So an example would be, I might have a bunch of features about a prospective shopper, let's say their age, maybe the things they had searched for would be in there encoded somehow, things of that nature. And then I would have an outcome, which would be like, did they buy a product, or what products did they buy? And then during model training, you provide all these examples, and then a model is the result of that. And then later on, you can basically use that model to predict the outcome from just the inputs. So in the example I gave before, you would, when someone is, if you're trying to predict while they're shopping what it is that they might be interested in buying, you have just those feature values as inputs. You feed that into your model serving system, and then you get out a predicted outcome.
So I'm trying to figure out where features fit and sort of the greater set of tools that you would use if we're talking sort of personalization here, for example. I do know, and having used some commercial personalization products, that there's different sort of algorithms that are used and different sort of models that are used or rather different sort of approaches to training, right? And being able to sort of produce recommendations. So if I like you example you gave, if I've liked a few things, searched for a few things, then this should be right the next set of things that you might like. Kind of like going on Amazon and you search for one thing, you see other recommendations, you're like, oh, I'm seeing things I didn't know I wanted.
Yeah.
Or you go to Netflix and you watch something and all of a sudden it's just recommending other things, right? So these kinds of recommender systems, it sounds like these are a kind of sort of a problem, right? That the features that you're creating, right, would feed into sort of helping these kinds of problems. So I'm trying to imagine in my head where in the layer of things needed to have a fully operational recommendation engine, right? What unit, where is the feature at? Is it one of the first things that you do as somebody who's building sort of a model, or once you train a model? Like, is it like what's the workflow like? Where does that enter the picture?
Yeah, so I think it is one of the first things you would start thinking about, but I think another kind of important aspect of MLOps in comparison to DevOps is that you have to go through a lot of cycles. So you might start thinking about features at the beginning, but to really effectively ML systems, you want to be able to quickly go through a lot of cycles where you build the features, you build a model, you see how it performs, and then that can give you more information about, maybe I need to tweak my feature definitions, or I need to get more data, or something of that nature. So I think it is one of the first things you would think about, but you also kind of have to be continuously monitoring how your features, what the values of your features are looking like, if you need to change the definitions, if you need to add new ones throughout the lifetime of the model.
So what makes features, I guess, sophisticated enough or complex enough to require their own data store?
Yeah, so there's a couple of interesting requirements from like a systems engineering perspective when it comes to feature data. One of the biggest ones is that I mentioned that you kind of end up using feature values in two main places. You use them once when you're building the model or training the model as part of your process of deploying like a machine learning system, but you also need to use it in production once you have the model deployed in order to actually make the predictions. And so it's the same sort of logic that defines the feature values, but you need to apply it in two different places. And you have different performance requirements for those two different use cases. So generally when you're making a prediction, in the context of most like recommender systems, for instance, you have a user generally that's kind of sitting there at the other end of the connection waiting for results to be ranked or something like that. So you obviously want that to happen quickly. That kind of online context, when you're making a prediction, the latency is very important. So lots of times people have requirements of something like 10 milliseconds in order to retrieve feature values, because that's only one piece of this whole process that has to happen of making a prediction. Whereas when you're training the model, the latency is not super important. I mean, you obviously don't want people sitting around for hours waiting for training to happen, but the throughput is more important in that case, because generally the more examples you can put into training, like the better results you're going to get. So it's kind of this, it's a different like set of priorities for those two different contexts that you need the feature values. And in addition to the performance requirements being different, generally looking for the freshest data. So you want the most recent version of a feature value. So like that doesn't make sense with the age example I've been using, but if you're talking about a feature that's like the last product that someone bought, you want that to be updated very quickly after someone makes a purchase, basically. So you want those to be fresh and have the most recent copy. Whereas in the training or offline contexts, you want to get the correct value for like a historical point in time. So you want to be retrieving the feature value as of the example that you're computing the features for. So the interface looks a little bit different in addition to the requirements for performance.
Would you say that the reason that feature stores kind of became a thing rather recently is that we expect faster everything, like you said, like fast search results and everything? So for example, feature stores were not really around 5 years ago.
Yeah, I think that's a big part of it, is like the performance requirements. I also just think that people are trying to deploy these machine learning systems in a much like larger variety of businesses and products than they maybe 5 or 10 years ago. Like really large tech companies have had some form of what I'm talking about for quite a long time, Google, Facebook, but now there's really like a lot of smaller organizations that are trying to build these types of things and running into these problems that like they can't, put as many engineers on as, a Google or a Facebook. And so there's a lot more interest in like trying to find these kind of off-the-shelf systems that help out with this.
Mm-hmm.
So given that this is sort of this falls in the category of sort of MLOps, as we've been referring to it, is this meant for the people that sort of operate these systems? Because it sounded like, I'm trying not to conflate the people actually building and training those models, right, with the people actually running those things, right? Yep. So there's a sort of there's a seam there, but I'm not quite sure where on which side of the fence basically the feature store users and operators fall.
Yeah, that's a good question. So, I mean, the answer is that both of those categories are users of feature store systems typically. And really, like, one of the most important things that a feature store can do is provide a clean seam between those two different roles. So, I mean, I briefly mentioned before, but like, before people were kind of integrating this feature store concept into their workflows, oftentimes the way a feature would make it into production would be a data scientist would kind of, do the exploration in the data, figure out, come upon insights and figure out what feature values they wanted. And they would generally test those out by doing, something like writing SQL, or maybe using a kind of ad hoc Python script and, cutting data up with pandas or something along those lines, that would produce data that was good enough to do the training, but maybe wouldn't actually meet the performance requirements of doing the actual online serving piece. And then often what would happen is that kind of, the SQL queries or the Python scripts or whatever they are would kind of just get handed to a data engineering team. They would have to decipher whatever it was that was going on and translate that into a system that could compute the features in real time. There oftentimes were mistakes made in that process. People didn't quite understand what was going on in one version or the other. And if you have discrepancies between the training system and the online system, it really, really hurts the performance of your model typically. So the whole idea with the feature store is that we can just have the data scientists define their features once in a way that they understand. So we support SQL. We also support defining them in Python if people prefer that. But once they've done that, it already is meeting the performance requirements that are kind of needed on the data engineering side. Because we, behind the scenes do a lot of like pre-materializing feature values and things like that in order to make sure that they can be served like promptly when they're needed by the model serving system. So we have one interface that's, or one part of the interface that's kind of focused towards the data scientists that are doing exploration, defining new features, and then another piece that is focused towards people that are operating the serving systems and integrating them into, CI/CD pipelines and things like that.
Yeah, a company I used to work for in the past, they had exactly what you described. There was the data science / engineering team who were building models and like taking data and crunching and coming up with new ideas and like new rules, kind of, if this, then perform this action. And then they would just hand over those Python chunks of code to the Go team, which is the backend team, and then now translate this into the system. That's exactly what it's solving. So it's been a couple of years, but yeah, that's very much in my personal world of context, at least.
That's not error prone at all.
Say again?
Yeah.
That's not error prone at all.
Yeah, even just translating from Python to Go, you lose some of that like precision that they found, or like something interesting.
Yeah, I mean, sometimes, model training systems can even kind of latch on to little quirks of behavior that like you wouldn't really think in this translation. But even if there's some edge cases where, certain numerical libraries you're using or something behave differently, it can really that are quite difficult to find.
Yeah. So we asked you to define some things, Mike, and I guess it covered a little bit what is your definition of MLOps, but maybe you can kind of say that for us. How do you see this, and how do you see this different from the DevOps and the infrastructure as a thing? So you mentioned, for example, how many life cycles?
Yeah. So, I mean, from my perspective, the most significant difference is that with DevOps, generally, you're talking about deploying servers or some other programs into production. So kind of got this pipeline that's going from some code in your Git repository or wherever it is, and then you're compiling it to these artifacts that end up in production. And of course, there's some steps there to make sure, maybe you're doing, canary deployments to make sure you're not breaking things, and you're testing and they work reliably. But the actual transformation of the code to the server is actually pretty straightforward and fast. And with MLOps, it's really kind of, it's just that process of transforming, the raw data into final product, which is like a model in this case, is really quite a lot more complex. So it takes longer, either because there's like manual steps that are involved, or because some of these training systems actually take a significant amount of computational power and time to produce the results. You've got different kind of involved with different stages of that pipeline. So there's data scientists, data engineers, so multiple different kind of stakeholders and people that are concerned with that pipeline. And so really it's just like there's a lot more complex pieces involved is the main difference that I see. In addition to taking longer, it's also with a kind of traditional, continuous deployment pipeline, it's pretty much only goes one way. So you have the code, you produce the server, you deploy it, and then that's kind of it. But with MLOps, you're sort of always continuously have this loop back. You're producing more data from the system that has the model deployed, which kind of gets fed back into the beginning of this process to become more training data for the model, which we'll then deploy later. So you kind of have this circular nature that makes it a little bit interesting as well. So yeah, I mean, I think that's really the biggest difference. I think a couple other things are, I mean, I mentioned this a little bit already, but you really have a lot of different kind of skills and roles involved with most ML systems than you do with a typical software system. So you'll have people that are just, straight up software engineers, they're data engineers, and then there are people who are data scientists who are like technical, but they understand things more in like statistics and math, and they have certain software tools that they want to use, like pandas, SQL, but don't necessarily like understand the whole I think a lot of data scientists wouldn't be super happy if you asked them to like set up microservices by themselves and things like that. And so I think you kind of have to, spend more time thinking about the different roles that are involved in making the system operate well, and make sure that you can kind of accommodate what they want to do at different stages in the pipeline.
There's two names for this, right? There's MLOps and there's AI ops.
Oh. Sounds like we're like, I want to say it sounds like we're splitting hairs, but I don't know enough to know for sure.
So I did a tiny bit of a research on, Google Trends and things like this. AI ops is more common in the Americas. ML ops is more common in Europe and Asia.
But they really mean the same thing?
It kind of means the same thing. I mean, of course, you can go into splitting hairs, but this is kind of practically interchangeable. And I was also curious kind of if you write that as one word or two words.
Well, I typically use MLOps actually.
As one word?
Yeah, I do.
As one word, and you're based in the US.
Yeah.
You're breaking the statistics.
Yeah. But I usually do like a capital M, capital L, capital O, and then the rest lowercase. So I don't know what the statistics are on that, but I think some people do it all caps. And there's a bit
any
of
other way, then
there.
it's just MLOps.
Yeah, it can be confusing.
What is this MLOps thing I keep seeing everywhere? Is that a new product?
Well, I'm happy to say that very few people actually write with a space, but I guess that kind of makes sense because you already write DevOps as one word, so it kind of continues that one. But if anybody was curious about that, here's all the information you need on the terminology.
I will say I am curious where Go fits into this wonderful world of MLOps.
Yeah, great question. So I can kind of give you some perspective on how we're using it at my company, and then maybe a little bit on how I think it's going in the outside ecosystem, although I'm obviously more familiar with what we're doing. So I mentioned this online serving interface for the system where low latency is one of the big requirements. And so that's primarily where we're applying Go at Tecton. So basically a server that we deploy for every customer that is taking in online requests for feature values. And we basically have a bit of a hybrid between pre-materializing the data, and then, so we have some of it pre-materialized, but we do some kind of final aggregation steps at serving time. And that's to make incremental updates easier when people need like frequently updated values. So we basically have a bunch of pre-materialized data. If we get this request coming in, aggregate, do final aggregations, and then return that result to the user. So it's a pretty straightforward thing it's doing, but like latency is really important, both keeping it low and then also keeping it consistent. Because typically people are concerned with, how their how their tail latency is looking. So you want to make sure that you kind of control that and keep everything pretty consistent. And so that's where we've deployed Go. The reason we chose Go for this use case, for me, the biggest thing came down to the tools that Go gives you for kind of doing performance tuning and being able to dig into performance problems, things like the built-in tracing and profiling, like we've used really extensively in order to meet our performance targets for this component. So I think it's worked out really great for us.
Was Go the first choice for this, or did you start something and switched?
Go was the first thing we used for this component. Yeah. We didn't, I'm trying to remember, it's been a while now. I don't think we super seriously considered other options. I mean, we kind of by necessity have a large part of the system written in Python because that's our SDK that we give the data scientists is, they're kind of expecting Python there. So, I mean, we probably briefly considered it, but I don't think it would have worked with the performance we have. Interestingly, we actually do have a Python interpreter embedded in this Go server because we allow people to do sort of we call them on-demand transformations. So they're able to put in transformations that run basically during serving time. I want to use that functionality to compute a feature which like a combination of something in the user's history, but also like a query that they're making that you're actively making a prediction for. So you might want to, have a feature which is like, it could be like a silly example would be like whether what the difference in the length of the query and the last query was or something like that. You would do that inside the Python interpreter inside on the feature server. So it is a little bit of a hybrid, but like 95% of it is all written in Go.
And now you have me curious about this thing you've embedded inside of the Go. So this is like an actual. So this is not like a you're getting like a raw Python string literal, and then you're shelling out to some Python runtime and then getting results back. This is like you're actually like interpreting the Python code and translating that into what you need to then do.
So we are running a full Python interpreter. We're not like translating the Python into some, that would be pretty cool, but we're not doing that, no. But
I'm like, you need to open source that thing.
Yeah, I mean, I have actually kind of looked into this. There are projects floating around that will let you do like basically compile Python down to LLVM bytecode or something, and then you could potentially link that into a Go binary. We haven't really seriously investigated that. I mean, most of these transformations are doing quite simple things. They're not super performance intensive, so we haven't really seen the need, but it's something we could look at doing potentially.
Interesting. So this was done really to solve not really a technical problem, but more of a meeting your users, like internal users where they are kind of thing. Because if Python is what they know and that's their tool, that's the thing that they know best, supporting that to some degree, right, was sort of the goal, not really because it couldn't have been done in Go, right?
Yeah, that was definitely the main thing, is that our customers writing these are primarily there's also a bit of thing with Python, and that you can just take definition as a string and just send it to the server, and so you don't have to worry about like linking it into the binary and restarting the server every time there's a new configuration, basically. That's something I'm sure we figured out with Go, but we just haven't really had like a strong need to do it. I know there are other systems like I might be mistaken. B&B has like published. They have like an internal products where I think they have an equivalent where they have people write the transformations in Rust, maybe, and they can make this whole thing like super fast. But I think that's kind of like an outlier case. Like most of our users, when they're writing these things, are doing very simple, additions or very small transformations that really only take like microseconds generally. So we haven't seen a need.
Would you say that Go is generally a good choice for machine learning ops, for MLOps? MLOps?
Yeah, I mean, I think so. I think you'll find kind of at the various layers of the MLOps stack, there are always going to be these components that are pretty latency sensitive. Like across most of the customers I've talked to, generally like pretty low latency for the end-to-end system is like a pretty important requirement. And I really like Go for that purpose. I mean, it's not necessarily that the language itself is somehow super fast compared to other languages out there. In fact, we've had issues with like the garbage collector and stuff that we might not have had in other languages. But for me, the tools that it gives you to kind of identify these problems and deal with them make it like a really good choice. So even if there are issues that come up, I'm like confident that we can like solve them quickly without spending a ton of time trying to figure out what's going on.
That is worth the price of admission, my friend.
Yeah, definitely. And I would say the other thing too is that in the kind of broader MLOps ecosystem, like I think a lot of people are kind of using Kubernetes as part of the solutions that they're deploying. And I found that just like being familiar with Go and the ecosystem is really helpful in that space, because it's like pretty easy to just, if you're confused at why something is behaving in a certain way, you can just like go look at the code, figure it out. So I think that's pretty helpful too, being kind of familiar with the ecosystem.
Mm-hmm. So you mentioned the toolings as a thing that is super useful for you in your world as a developer in the world of MLOps. Interesting. I would really expect that you would also mention something like the speed of the language, because it is really fast.
Yeah, well, I mean, it is certainly fast compared to something like Python. I mean, in my previous life as a software engineer at Google, we were mostly using C++. So it's like compared to that, it's not like intrinsically faster, right?
That's fair. Okay.
And so for me, I guess, given my background, I just look at the tooling and the ease of making everything work is the main advantage. But I guess if you were coming the other way from like having written a lot of Python, it would probably be a different story.
It's all relative.
Yeah.
When did you start writing Go? Why? What got you into this?
Yeah, so it was at Google. I think I was trying to remember before I came on here. I think it was probably around 2015 was the first time. And it was not kind of the primary thing I did there. So like I said, but I worked a lot on the basically experiments system for web search at Google. And a big piece of that was that all of the different front ends that were serving Google search would be basically creating kind of structured application logs of everybody's interactions constantly. And they would all get crunched down into a bunch of business metrics every day. And those metrics were what drove all the experiments that were going on at Google, basically. There'd be like thousands of these experiments running at a time. And the whole pipeline for crunching all of those logs down into metrics was, at the time I was involved with it, written in Go. And it still is. It was, before that, had been all written in this like domain-specific language called Sawzall, which was actually created by Rob Pike. So there's a bit of a connection to Go there as well. But yeah, at the time I was working on it, everything was in Go. That system had there were a bunch of different teams at Google that would contribute their own metric to it. So like the image search team would have metrics having to do with images. There would be some that were common across all the different search properties, but basically there were like a ton of people contributing these metrics. And so there was a library for creating, and I spent some time working on that library because we were changing how things were logged in search front ends. And so we had to make sure that people, we weren't breaking people's metrics when we were doing that. So that's how I got involved writing Go. Basically, it was trying to not break people that were downstream of the changes I was making.
And that's also, would you say, the main language for you now, right? Some Python, but mostly this.
Yeah, we've got definitely a mix. All of our online serving stuff is written in Go. There's the Python for the customer-facing stuff. And then just for variety, we have Kotlin that's involved in some of the more kind of like management and orchestration systems that are kind of off to the side.
And Feast is the open source project, right?
Yes.
And it has some Go. It
has some Go. I am frankly less familiar with the exact composition of everything on the Feast side. They're a lot more Python focused because they basically run a lot more of the feature source system sort of inside the client, whereas Tecton's kind of architected with more things living on the back end. But they do have some Go mixed in there as well.
Okay, so anybody who's listening and wants to dive into this a little bit by contributing code can do this in the repo of Feast.
Yeah, Feast is a good place to start.
I love the wiki and I love the documentation, I have to say, of Feast. It's a great job with that.
Yeah, they've done a really good job with all that stuff.
Cool. Okay. And Johnny is like, as we laughed earlier, quickly skimming through everything, and now is becoming the expert.
Ingesting data, yeah. Like next week, interview me on MLOps. I'll have all the answers.
But then I will include the question on the difference from MLOps to IOPS. Okay. Cool. And then I guess comes the fun part. Unless, Johnny, you want to ask anything before we start talking about unpopular parts?
Let's get to the unpopular stuff.
All right.
Unpopular opinion. I actually think you should probably leave. Unpopular opinion.
So I don't know if I'm supposed to say this, and I'm sorry if not, but the performer of this wonderful song has a birthday today, finally turning 18. So if you see Matt on Twitter, wish him a happy birthday. But only if you're listening to the live recording. Actually, you know what? Even if you're listening afterwards, just say hi to Matt. You don't need to say happy birthday. Just say, hey, Matt.
He's finally an adult.
Maybe he'll grow up. No, that's an unpopular opinion, I guess. Matt, we love you very much. It's all in good vibes. Mike, do you have an unpopular opinion for us?
Yes, I have an unpopular opinion. So it's not tech related, which I hope is okay. But
it's all good.
That's not popular.
Yeah, I really just don't like maple syrup. Is my unpopular opinion. Even on pancakes, on waffles, I just don't do it. So that's my opinion.
Okay.
Johnny, I saw a tweet from you from the weekend that you were making pancakes.
Yeah. My I have young kids and they love themselves a pancake, especially the syrup.
Yeah. It seems almost universal, just not for me.
What don't you like about it, Mike?
I think how sticky it is a big part of it, but also
is it more or less sticky than honey?
Somehow it feels more to me. I don't know if that's chemically accurate, but that's my perception anyway. And we've got a lot of Canadians working at Tecton, actually. In fact, the CEO is Canadian. So I hope that they hear this, I don't get, ostracized.
They'll ask you,
But you don't like syrup, eh? Well, there you have it.
Yeah.
Unpopular opinion.
I think the most funny opinions we have is in the context of food. So great choice for an unpopular opinion. There will be a Twitter survey. We will see how unpopular is your unpopular opinion. And
Okay.
you might get into the top 5 or the low 5.
Are you supposed to have the most people disagree with you?
I mean, it's a goal. We all have life goals, so why not this one?
Okay. Well, hopefully I do well then.
Cool. All right. Well, that was a very interesting conversation. And I think it's a rather new field, at least in our context of Gophers, this MLOps in general, but also feature stores in specific. And we will be providing links for you to learn if you want to dive into that or if you want to contribute code to Feast. And we also want to say thank you to Mike for joining us and for teaching us so many interesting things.
Yeah,
Indeed.
thank you for having me.
Thanks, everyone.
All right, y'all.